My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 618. In this lecture, we will try to understand about VGGNet. In this particular lecture, I will refer two papers, or I can say one important paper. This is a paper which I refer. What is this paper? Very deep convolutional neural networks for large scale image recognition. Just I request all of you to refer this paper. Just try to understand few concepts in this paper. Anyway, I will explain the concepts which are in this particular paper. This is one of the famous paper. It is well known paper in deep learning. In similar manner there is a Quora question. What is that? Just let me show that one also. Yes, just go through this paper. This is a very important paper, and this author Andrew Gisserman, he is also famous deep learning engineer. Anyway, we will see all those things. Also, I will refer this Quora question. What is the VGG neural network? There is a nice answer by Yugandhar Nanda. This also we will discuss in this particular lecture. Anyway, let me go back to my slide. What it says, just see, in this particular lecture we will try to understand VGGNet. The next very important research paper is from 2015. This paper is actually published in 2014, but it is accepted for ICLR, which is very popular conference in 2015. Yes, this is we just take it as 2014 because the first version of paper is published in 2014. This algorithm is called VGGNet. It's called VGGNet because of the group that built it. Which group? It is called VGGNet because of this group. Group name is Visual Geometry Group. That's why people are calling it as VGGNet. For those of you who may not know, Andrew Gisserman is a legendary figure in the area of computer vision. There are lots of brilliant textbooks written by Andrew Gisserman, and he is a professor at Oxford University. He is like a seminal figure in the area of computer vision. Andrew Gisserman has phenomenal team called the team name is called Visual Geometry Group. It stands for VGG. This is a research group at Oxford University that is headed by Andrew Gisserman. VGG is simplified, I can say. I request all of you to go through this Andrew Gisserman's home page. Yes, I can say VGG is simplified version of AlexNet. Otherwise, actually it is better version of AlexNet. I should not say simplified version. AlexNet, if you recall, had lot of kernels. Just try to recall AlexNet. It had lot of kernels. What is this kernels? Just try to recall AlexNet. AlexNet had 11 by 11 kernels, it had 3 by 3 kernels, it had 5 by 5 kernels, and all sort of kernel. So the core philosophy behind VGGNet is, can we simplify the network somehow? That's the core philosophy. What is the core philosophy here? Just see, the core philosophy behind VGGNet is, can we simplify AlexNet somehow? In the case of AlexNet, it has got, we had 11 by 11 kernels, it had 3 by 3 kernels, 5 by 5 kernels. It's a little bit complex. Can we simplify? The core philosophy behind VGGNet is, can we simplify AlexNet somehow? And the simplifications comes from by saying that we will only use we will only use. How can I simplify AlexNet? The simplification comes by saying that we will only use 3 by 3 kernels, and it what it says, we only use 3 by 3 kernels, and its stride equal to 1 and padding p equal to same. So all convolutions that you are performing will be of size 3 by 3 convolution. It's not like earlier what happened in the case of AlexNet, 11 by 11 kernels, 3 by 3 kernels, 5 by 5 kernels. No, there is a change. What it says, all the convolutions that you perform will be 3 by 3 convolutions, which is stride of 1 and padding as same, isn't it? 3 by 3 kernel, stride of 1 and padding as same. All max pooling that we will perform, max pool kernel size will be 2 cross 2 with a stride of 2. By fixing that every convolutional layer, every convolutional layer has 3 by 3 kernels, stride equal to 1, padding equal same, will have the same convolutional operator of the same size. No more 11 by, in the case of no more 11 by 11 kernels, no more 3 by 3 kernels, no more 5 by 5 kernels, just like AlexNet, isn't it? Here only you are using 3 by 3 kernels. Here you only have 3 by 3 with stride is equal to 1 and same padding. Whenever you have max pooling, you only have max pooling kernels of 2 by 2 with the stride of 2. By having the same type of convolution every time you have convolution and same type of max pooling, the architecture gets simplified dramatically. So in this research paper, there are two models. There is something like there are two in this particular research paper. There are two models. There is something called VGG16 and VGG19. So VGG16 is the 16-layer network. VGG19 is a 19-layer network. They are more or less very similar, even in performance. They are very, very related. But I personally prefer 16 primarily because it has fewer layers, and in terms of performance it's not significantly worse than VGG19. But you can say you can use any of them. Means you can use VGG16 or VGG19. Today lot of people use VGG networks as a default network, isn't it? I will repeat, today lot of people use VGG networks as a default networks when they have to do some form of computer vision task. So there is a research. So there is a research paper by Andrew Gisserman and his group. In this research paper, they actually explain the architecture like this, which is this is the architecture. Andrew Gisserman and his group explained the architecture like this. But problem is, I will repeat, in this research paper, in this research paper they are actually explained the architecture like this, which is harder to understand in general. So there is a very nice answer on Quora. There is a brilliant answer on Quora by someone called Yugandhar Nanda. Very, very brilliant answer. It's a brilliant answer. He explains, I really like this answer. The question is, what is the VGG network? You have to detect 1000, it's not 1000 images, actually it is 1000 classes. There is some mistake here. This is not images. You have to detect what you have to detect. You have to detect 1000 classes, isn't it? Detects. So I will repeat. You have to detect 1000 classes, not images. Here it detects one of the 1000 classes. Here convolutions are always like 3 by 3 size. Just see, your convolutions is always. That's what we are discussing. Convolutions is always 3 by 3 size. Max pooling layers, just see, max pooling layers is always 2 by 2 size. fully connected layers. That's what we were saying. And total how many layers? There are 16 layers, and you have nice accuracy. Just see here, model size, you have your type 1 accuracy is this one. You have nice accuracies, and you can get the pre-trained models and stuff like this. And this is VGG19, and this is one way of looking at. Also look at the architecture here. This is your let me show this architecture once. This is, let me say, this is your input this is your input. On the input you have 3x3 convolution. Just see, you have 3x3 convolution. So after two convolutions you have max pool layer. Here again after two convolutions I have max pool here. Here after three convolutions, here I have, after, just observe this one, after two convolutions max pool, after two convolutions max pool, after three convolutions max pool, after three convolutions max pool, after three convolutions max pool, fully connected, fully connected, fully connected. This is the simple architecture. That's what it says. Anybody can understand it. This is fully connected, much. Just if you observe, FC means what? It is fully connected, isn't it? Much simpler, because look at all your convolutions. Just understand, all your convolutions are only 3x3, as we discussed earlier. All convolutions are of size 3x3 with stride equal to 1 and padding as same. All convolutions are again I am repeating, all convolutions are size 3x3, s equal to 1 and p equal to same. S means stride equal to means, p means padding equal to same. Similarly, all max pools have kernel 2 cross 2 with stride s equal to 2, isn't it? Why are we doing all these things? Thereby simplifying the whole model. Actually, that's the visual way of imagining it. Just I request all of you, just go through this Quora answer also, and just try to understand this lecture. I will continue my discussion on VGGNet in my next lecture also, that is in lecture number 619. Thank you very much.